Alright, sorry my video cut out there. My phone doesn't like it when these videos get too long. So basically I'm just recapping this last step. I've got trying to get opposite coefficients here to get a 0 on the bottom left. So I took -2 times the row 1 entry. -2 times 1 equals -2 plus 2 gives me 0. And then we did the same thing here. I did -2 times 0 is 0 plus -3 is -3. And then we do that again here. -2 times -1 is 2. 2 plus -8 is -6. So put the -6 in. Top row remains the same. Okay. And now notice that in this bottom row, it's essentially what we had in the elimination method here, except I've got a pair of negatives. It's -3 and -6, whereas here I had +3 and +6. You know, if you multiply both sides by a negative, you get the same thing. So it's essentially the same. And then finally, I need a 1 in this bottom right number instead of a -3. Well, how do I get a 1 there? I just divide by itself. And so I'm going to rewrite that matrix. 1, 0, 0, -3, -1, -6. Again, that's the new little r1, little r2. And slide that up. So then I'm going to take the new row 2 to be -1/3 of the old row 2. Pretty simple. So -1/3 times 0 is 0. -1/3 times -3 is 1. -1/3 times -6 is 2. And then the top row remains the same. Okay. Now notice I've got my 1, 0, 0, 1, and I've got my -1 and my 2, which were the answers. So my left side is in reduced row echelon form, and the right side does represent the correct answer. Okay? Awesome. So this is the process you would take. Now, I chose 4 specific steps that I thought would get us to the reduced row echelon form in the most efficient way. There are many other ways to get there. And I'm not even going to guarantee that this is the most efficient way. Actually, it's the way that I could get it to most accurately represent the elimination method. So it kind of worked out nicely that way. But in general, there are many ways to do this, and there's not really one correct way. I'm actually not going to have you work any of these out in their entirety from start to finish using the row operations. You are, in the My Math Lab homework, going to be required to do individual row operations using this notation. So it might give you one matrix, it'll give you the notation for the row operation, and you've got to give the next matrix. So it'll be much simpler than this process. This is the whole thing. You'll just be asked to do one step of it. Yeah, now your calculator, that's where I really want to focus the rest of this conversation, can do all of this stuff much quicker, obviously. And so that's what we're going to work with is our calculator for a little while. Ooh, that glare is bad. Okay, so with the calculator matrix, actually I'm going to get a new sheet of paper here so we can write out the instructions. Alright, so the initial matrix was 1, 3, 5, and 2, negative 3, negative 8. Basically, your calculator, we can input this into the calculator, and it will be able to calculate the reduced row echelon form automatically. Okay, so to do that, on your calculator, you're going to go to your matrix menu. I'll show you where that is. You hit the second button, and then the X inverse button has the word matrix above it. I don't know if you can see it with the glare there, but you can see it at home on your calculators. The matrix button. Okay, so we're going to hit the second button. I like to write these instructions out, followed by the X inverse button, and that gets you to the matrix menu. Okay. Once you're in the matrix menu, let's see if I can get this all on the screen. It's probably not too bad. Once you're in the matrix menu, you're going to go over to the edit menu, EDIT, and you're going to select, we're going to select the first one for right now. So I'm going to select option 1, which is matrix A. Now your calculator uses variables, capital letters, to represent a matrix, so it's using this notation for matrix A. Inside matrix A, you're going to need to give the size of the matrix, which is not something I've talked about yet. The size of the matrix is going to be the row by the column. So you enter row by column. Now the number of rows by the number of columns. So this is going to be a 2-row matrix, right? It's got 2 rows horizontally by 3 columns. And when you enter 2 by 3, now yours probably won't have these numbers in here. This is just an old matrix that I've had in there. But you'll get the right number of rows and columns once you enter it in. Then you just type over top of all these entries. So I want 1, enter, 3, enter, 5, enter, 2, enter, negative 3, enter, negative 8, enter. And now I've got my matrix entered. Okay, so we're going to enter cells. Okay, there's the numbers in each cell. I'm just abbreviating some of the stuff. Then we're going to exit the matrix. So we're going to hit, to do that, you're going to hit second and then the mode button to quit. So second, mode, and that gets you to the quit. Okay. Next, we're going to actually calculate the reduced row echelon form. So we're going to go to the matrix menu again, second matrix. So I'll skip a little space here. Second, the X inverse button to get to the matrix menu. Okay, then you're going to go over to the math menu. This is where we do the operations on matrices. We'll probably end up doing some other ones here in the next couple sections. We're going to go down, scroll down, way down till you find RREF. It is option B. RREF, and then it has a parenthesis. So hit enter on that. Slide this up a little bit. And it will show the RREF on your home screen. Now you want to tell it what matrix to reduce. So you have to go back into the matrix menu. So you hit second, and then the X inverse again, and that gets you to matrix. Okay. Under names, the names menu, you're going to select the one that we just entered, that matrix A. So you hit enter. So we want 1, which was A again. And then you're just going to close your parenthesis. Yeah, close your parenthesis and hit enter. So close the parenthesis, which I'm running out of space here, and hit enter. And you will have a matrix which is in the reduced form. There's our reduced row echelon form. Now your calculator doesn't put the little vertical line in there, just imagine that it's there. This is our augmented matrix for the final form. Now when you guys are doing work, I'm going to allow you to use your calculator to do these steps. So I'll leave that up there so you can kind of see it all in one view. When you do these on a test, I am going to require you to show some work. Okay, so you're going to need to show the initial matrix. You're going to need to show this final matrix, which is 1, 0, 0, 1, and then the 1 and or negative 1 and the 2. And then you're going to need to represent the final answer as a solution set to show that you can interpret that properly. So when you do this on a test, if you're using your calculator, there are 3 things you need: the initial matrix, the final matrix, and the reduced the solution set. Okay. All right.